This was my final project of my grade 11 year, my LongISP. For this project, I designed and built a watch winder. When complete, this will wind an automatic watch and charge it. This project used a MOSFET. In their most basic form, MOSFETs are like switches. They're like more advanced transistors. MOSFET is short for metal oxide semiconductor, which are the different layers that make up a MOSFET. When you look at the MOSFET from this angle, you can imagine the light gray layer as being the metal, the darker gray layer as being the oxide, and the blue layer as being the semiconductor. The left and the right side greens are both the drain and the source, and the middle lead is the gate pin. Because of the way the drain pin and the source pin react with the metal around them, they're shrouded in electrons even when no power is going through the rails. When the voltage flows from the drain pin to the source pin, a depletion reaction is created, causing a voltage drop between the two of them. This depletion reaction means that there is a threshold voltage from power to pass from the drain pin to the source pin. This means that power will only start flowing through when there is current flowing from the gate pin, meaning that this is when the circuit will turn on, acting like a switch. A gearbox was also used that had a 30-to-1 gear tooth ratio, which meant for every 30 turns of the stepper motor, the watch would turn once. Because of the way I've set up this gearbox, there's also a belt-driven system, which means that for every 10 spins of the stepper motor, it spins the first part of the gearbox once, which equates to a total of a 300-to-1 gearing ratio. This was built off of a voltage divider circuit using a voltage read in the code to see when to turn the motors to high and when to low.